Coming up in this video, we're going to be allocating the terms from waiting analysis in enterprise dynamics. So that will be U, NQ, N, WQ, and W. So here we have our first system simulation. The first thing we can notice is that every step is connected in a series fashion, as opposed to parallel. So the orange squares represent servers in the system. So in this case, we have 4 servers. We have preparation, production, finishing, and inspection. Under the server's name, we can find the utilization rate of that server. The blue square represents queues in the system. So in this case, we have 2 queues. And the number below is the number of products at the queue. We also have the process step arrival and ready. And the number below is the number of products in those process steps. Along with this, we might get some extra information. For example, the time of the job of every server. So in this case, preparation is 36 seconds, normally distributed with 4 seconds of standard deviation. Production is 72 seconds, negative exponential. Finishing is 40 seconds, also negative exponential. And inspecting has a uniform distribution between 50 and 70 seconds. We might also get the arrival rate, in this case is 2.5 per hour. And the simulation time is approximately 16,000 hours. Now let's take a look at a data sheet. We have 3 columns: content, throughput, and state time. Let's take a look at each one of them individually. Let's start with current. The column current is not very relevant because it states the number of products at the end of the simulation, and we cannot work out any information with this. The next column is average, and this is more relevant because it states how many products are on every process step on average. So we can work out the terms NQ here. If we add up the average products in queues, we get 111.8. And if we add the products in the servers, we get on average 116.44. Now let's take a look at the column throughput. Throughput is the number of orders that have entered and left a certain process step during the time the simulation has run. It's important to know the first input because we can implement that data in this formula right here. Simulation time is the input over the arrival rate. So the input in this case is 40,355 and the arrival rate is 2.5 per hour. We divide that, we get a simulation time of 16,142 hours. So that's important to know. What is also important to know is the last number from the input column, because it gives us the total amount of products produced. So in this case, 40,223. The last column is state time, and this column is connected to W and WQ, the waiting times. So in this case, if we add up the average state times at Q, we arrive to 133.2 minutes of waiting time at the queue. And if we add the remaining average state times to this number, we arrive to the total waiting time at the system. That will give us 137.7 minutes of waiting time in the whole system. That's only 4 minutes longer than the waiting time at the queue. So why is this happening? Why is the waiting time at the queue such a big contributor of the total waiting time? Well, let's take a deep dive into the system and see what we can find. So production is negative exponentially distributed with an average job time of 72 seconds. And if we take a look at the average state time of the process step, we see 71.5 seconds. So the numbers are fairly close. Now preparation has a time of job of 36 seconds. However, if we see the data sheet, the average state time is 72 seconds. That is because the pace of preparation is faster than the pace of production. So as soon as the queue before production gets filled to its maximum capacity, the products at preparation will have nowhere to go, and as a consequence, this process step will be blocked. So the average state time of preparation will be the time of job plus the block time. Inspection takes on average 60 seconds, and that is what we also see in the data sheet. And because this is the last step, there is no blocking time. The time of job of finishing is 40 seconds, but this process is blocked too due to the pace of inspection, which was on average 60 seconds. But the average state time is even more than 60 seconds as a result of the negative exponential distribution that brings variation to the process. When working with a system where the servers are positioned parallel to each other, there is a distinction when we're calculating the waiting times. The best way is to use the weighted average formula. So we would add the input times the average stay time of each server divided by the sum of the input number of every server. So in this case, we arrive to 242 seconds. Once we have that number, we can add the remaining average stay times and arrive to the total waiting time of the system. We can also calculate the arrival rate by using the formula shown in previous slides. So we will divide the input by the simulation time. So in this case, we have 29 products per hour.